On work energy power. These numericals are quite easy and scoring. First numerical reads, calculate the work done when a load of 10 kg. Whenever it is written 10 kg, so it is mass, is lifted through a height of 20 meter. Value of G is given 10 meter per second square to simplify the calculation. Now, work done in lifting load you should learn is mgh, where m is mass of the body, g is acceleration due to gravity, h is the vertical height. So, just substitute the values, you will get the answer. M is 10, g is 10, h is 20, so you will get 2000 Newton. Is it alright? So, now we will go to sum number 2. A force of 20 Newton displaces a body through 5 meter. So, displacement is 5 meter, force is 20 Newton at an angle of 60 degree to its own direction. So, body is getting displaced at an angle of 60 degree to the direction of force. So, theta is 60 degree. So, what is work done by the force? Fs cos theta. Most important formula of this chapter, work done is Fs cos theta. So, substitute the value of F20, substitute the value of S as 5 and theta as 60. So, cos 60, I hope you remember the value of cos 60. Cos 60 value is half. So, if you multiply, you will get answer as 50 Newton. So, this completes sum number 2. Now, we will go to sum number 3. Calculate the work done in arcs. So, this is a sum in CGS. Force is 15 gram force. So, 15 gram force is the force. So, what is the force in dyne? Because in CGS force is measured in dyne. So, 15 gram force is 15 multiplied by 980 dynes. So, that if you multiply, you will get 14,700 dynes. So, this is the force. So, always our unit should be proper. It is displacing through 2 centimeter. So, S is 2 centimeter. It is in the direction of force. So, W is equal to Fs cos theta. F we had calculated 15 gram force had come to 14,700 dyne. So, F is 14,700. Displacement is 2 centimeters. So, multiply by 2. Theta is 0 degree in the same direction. So, cos 0 is 1. So, if you multiply, you will get 29,400 ergs. Okay. So, now we will go to sum number 4. How much work is needed to be done on a ball? So, now in this sum we have to find W. Mass is 100 gram and we want to give a momentum of 2.5 kg meter per second. So, part of the data is given in SI and part of the data is given in CGS. So, let us do the sum in SI system. Now, what is momentum? Mass into velocity. So, P is equal to m into v, where P is momentum. So, what is velocity? So, velocity will be P upon m. Substitute P as 2.5 and substitute mass as 0.1, 100 gram in kg would be 0.1. And if we simplify this, we will get 25 meter per second. So, this is my velocity. Now, knowing velocity, we can find the kinetic energy of the ball. Kinetic energy is half mv square. So, half, mass is 0.1, velocity is 25, which we have calculated earlier. It will be 25 square. So, if I do this calculation, I will get 31.25 joule. So, the kinetic energy of the ball is 31.25 joule. Initial kinetic energy was 0. So, increase in kinetic energy 31.25 joule. By work energy theorem, whatever is the increase in kinetic energy, we have to do the same amount of work. So, work needed to be done on ball is 31.25 joule. Is it all right? You can note down this before we proceed to next slide. Now let us do the next sum. This is quite important sum. In this sum, this is an inclined plane. CAB is an inclined plane in which a body shown in blue color is shown. Now the body is moved along the inclined plane by a force of 20 Newton. And what distance it travels? It travels a distance of 5 meter. The mass of the body is given to be 3 kg. So this is mass of the body. It is moving a distance of 5 meter along an inclined plane. So this is an inclined plane. It is moving a distance of 5 meter. So force is also applied parallel to the inclined plane. So angle between force and displacement is 0 degree. So he says in the first part, what is the work done in pulling the body along the inclined plane? So work done would be Fs cos theta. Now force is 20 Newton, distance travelled is 5 meter and theta is 0 degree. Theta is the angle between force and displacement. So force is in this same direction and displacement is also along the inclined plane. So work done is 100 joule. So a person will have to do 100 joule of work in moving the body from A to C. Now when I am moving the body from A to C, my body is getting lifted up. So that is the second part of the question. What is the work done against gravity? So what is the work done against gravity? So work done against gravity means I should take the distance in the vertical direction. So that distance I have shown as h in the figure. So this is my h. So this is the vertical distance I have moved the body BC. So if I consider triangle ABC, what is sine 30? This angle is given to be 30 degree. What is sine 30? Sine 30 is h upon 5. Opposite side upon hypotenuse. So I will get h as 5 sine 30. So this is, I have got the value of h. Now work done against gravity is always means it is just like lifting the body, is mgh. So work done against gravity is mgh. Mass is 3 kg, g is 9.8 and h is my 5 sine 30. This is my h as I have calculated here. So h is 5 sine 30. If you do this calculation, work done against gravity is 73.5 joule. Then remaining amount of energy, which is 26.5 joule, where it has gone? It has gone in overcoming the frictional force. So 26.5 joule of energy has been spent in overcoming the frictional force because the body was moving up, so frictional force was always will act down. Frictional force always acts in the direction opposite to motion. So I had to apply certain force to overcome this frictional force, and that force comes to 26.5 joule. So that is the energy spent in overcoming friction. Is it all right? You can note down. So then we proceed to next sum. Next sum says a boy of mass 35 kg, mass of the boy is given. Now he is climbing 40 steps, each 15 centimeter. So what height he is climbing? 40 into 15, that is 600 centimeter. So that comes to 6 meter. So the height climbed by the boy is 6 meter. Is it all right? So this is the height climbed by the boy is 6 meter. So height climbed by the boy is 6 meter. Now work done by the boy would be Fs cos theta. What is force boy has to apply? He is lifting himself. So means he is moving a mass of 35 kg. So F is 35 kg and G is 10. So this is the force he has to exert for him to get lifted up. And to what height? 6 meters. So this is mgh cos 0 because he is moving vertically. We are taking 2100 joule. Similarly, work done by girl. So here mass of girl is 26, So 26 into 10, height is same, so will come 1560 joule. In this sum, we have also to calculate the power developed. Now power of the boy is work done upon time. What is work done? 2100 joule. Time taken is 2 minutes. That comes to 120 seconds. So it comes to 17.5 watt. Now power of the girl is also work done upon time. Work done is 1560 joule and time is 1.5 minute. So that comes to 90 seconds. So this is the power of the girl. Is it alright? So now next three are quite simple orally. He wants to check the concepts. A coolie and height of coolie is 1.8 meter. Is carrying a load of 40 kg. Is carrying a load on his head. He is not lifting. So work done by him would be zero because there is no displacement. The load is remaining stationary on his head. So unless there is a displacement, no work is done. Next, a body is moving in opposite direction. Body is moving in opposite to the direction of applied force. So displacement is in opposite direction. Therefore, the work done would be negative because theta is 180 degree. So work done by the force would be negative. A satellite of mass 5 ton rotates around Earth. So a satellite is rotating around the Earth. Okay, this is Earth. This is Earth. Satellite is rotating around this Earth. So this is the radius. So at any point the satellite is moving perpendicular to the radius. So displacement is and force here is centripetal force. Displacement and force are at 90 degree, cos 90 is 0. We have learned that body moving in a circular path does no work. So the work done by the Earth's gravitational force, which is providing the centripetal force, would be 0. So work done would be 0. Is it alright? So we'll go to next slide. This is quite simple. A weightlifter is lifting a load of 100 kg. So what is the load? 100 kg. So weight is 100 kg. Question number 10 reads, a weightlifter lifted a load of 100 kg to a height of 5 meter. So we are given the mass of the, we are given the height, we are given the time. Work done. We are also given G. So what is work done? mgh. Mass is 100 kg, G is 10, height is 5. Because we are lifting vertical, so theta does not come into picture. Theta is 0 degree. So we get 5000 joule. Power developed. Power is work done upon time. So 5000 and how much time he has taken? 2.5 seconds. So it will come 2.5 minute, not it is 2.5 minute. So it will come to 150 seconds. So that will give me 33.33 watt. So this is the power developed. Then next sum. Sum number 11. Water pump raises 100 liters of water. So this is volume of water. We know density is equal to mass upon volume. So mass of water is always given by density multiplied by volume. So density of water is given to us 1000 kg per meter cube. You should also know the relation between liter and meter cube. You can write down 1 meter cube is equal to 10 raised to 3 liters. Okay. So we have to calculate power of the pump. So mass of water raised is 100 into 10 raised to minus 3. This will give me the volume of water in meter cube. Because 1 meter cube is 10 raised to 3 liter. So 1 liter would be 10 raised to minus 3 meter cube. So I am getting mass of water raised as 100 kg. So this is the mass of water raised. 1000 is the density. This is the volume in meter cube. This is volume in meter cube. This is density. So this is in SI system 100 kg, because I am using the sum in SI system. So mass of outer disk is 100 kg. So work done is mgh. So 100, g is 10 and height is 25 meter. So I have got the work done. Power is work done upon time. What is the work done? Work done is 25,000 joule and time taken is 10 seconds. So divided by 10, I will get 2500 watt. Okay. So we go to next sum. Now next sum is on different topic, pendulum. The pendulum is oscillating to a maximum height of 5 centimeter. We have learned if this is the pendulum, it will go in this direction. It comes up to here. So this is the height from this mean position, and then it will also travel here. These are called extreme positions of the pendulum. This is called the mean position. So this is the height. The pendulum is going from this rest position when it reaches to the extreme position of one side. So when it reaches extreme position, the height is 5 centimeter. So if mass of the bob of pendulum 50 gram, so this mass is 50 gram, G is given, calculate total energy of pendulum. So when the pendulum is at any extreme position, like suppose pendulum is here, so in this position, what is it has got only potential energy, so mgh is kinetic energy here is 0 because it is having no velocity. Pendulum has no velocity here, so k is 0, so the total energy would be mgh. To substitute the values, mass as 0.05 kg, g as 10, h as 0.05, so we are getting so many watts. Now the second part of the question is velocity at the mean position. Now at the mean position, pendulum has no potential energy but only kinetic energy, and kinetic energy is given by half mv square, where v is the velocity. Now total energy at extreme and at mid position remains same if there is no loss of energy due to friction. So that is our assumption. So if I put the values, half mv square is equal to the total energy which I have calculated here. So from here I can do algebra and get the value of v. And so v comes to 1.1 meter per second. Is it all right? So we'll go to next numerical. Number 13. A ball of mass 0.2 kg is thrown vertically up with an initial velocity of 20 meter per second. So initial velocity is given to be 20 meter per second. So that is u. Then he says the ball will, up to what maximum height the ball will go. So ball will go to maximum height. See, I have thrown the ball from here. So the ball is going up. At maximum height, its velocity will become 0. So v is equal to 0 at maximum height. This is very important. You might have done this in 9th standard. When the maximum height reaches, at that point the velocity of the ball is 0. So we will do that concept, that what I have written, at maximum height v is 0. So we are using third equation of motion, v square minus u square equal to 2as. This is 0. So my h would be u square upon 2g. Now my value of u is up. When I am throwing the ball, up. So value of u is up. The value of displacement is also up, but value of acceleration is down because the velocity is going on decreasing. So g is minus. So both this negative will get cancelled. So I will get s. S means h equal to u square upon 2g. So I have substituted the value of h equal to u square upon 2g. This is my u square, 2g. So this is the value of maximum height at which the ball will go. At this height, the velocity would be 0. So what is the work done? mgh. Mass is given, g is given, h I have calculated. So I am getting the gravitational work done in throwing the ball up. Okay. Now we'll go to next sum. Question number 14. Find the power of water. So means first we should find the work done upon time is power of water. So find the power of water flowing through the dam, height from which it is falling 50 meters. So this is the h I am given. So this is my h, 50 meter. Volume is given 240 cubic meter per minute. Now 240 cubic meter per minute. I told you that density of water is 1000 kg per meter cube. So mass of water is volume into density. But because I have given per minute, so I am dividing by time to get into second. So my t is 60 seconds. So that I will get the volume mass of water flowing per second. Mass is volume into d. D is density. This d is density of water. So volume is 240 meter cube, density is 1000. To get per second, I am dividing by 60. So I am getting mass of water flowing is 4000 kg per second. Now power is equal to work done upon time. So t. So but t is 1 second because my mass is 4000 kg is flowing in 1 second. T is 1 second. I have already made t as 1 second. Mass is 4000 in 1 second. G is 10. Height is 2. So I am getting 2 into 10 raised to 6 watt, which is nothing but 2 megawatt. So 2 megawatt is the power of water that is flowing from the dam. Okay. Now next sum is also very interesting. Work done by heart for each beat. So for each beat, when the heart beats once, the work done is 1 2. So the heart is beating how many times? 72 times. The heart is beating 72 times in a minute. So 72 times means how much energy? 72 joule. So work done by the heart is 72 joule in 1 minute because 72 beats are in 1 minute. So work done per minute is 72 joule. So power of heart is 72 upon 60 time 1.2 watt. So this is the power of the heart. Okay. Next sum. If power of a motor is 80 kilowatt, 80 kilowatt means 80 into 1000 watt. So that's what I've written here. Power is 80,000 watt. Now at what speed it raises the water? Now I have given 2000 kg is the mass of water. So at what speed? So let my speed be s meters per second. So again my time is in per second. So it will give me directly power. So s meter per second. Work done is mgh. Mass is 2000 kg. G is 10 and h is s. In how much time? 1 second upon 1. And this power I know is 80,000. So 80,000 is equal to 2000 into 10 into s upon 1. So this will give me 4 meters per second. That is 4 meters. So this is also per second. So the water is getting raised at a speed of 4 meters per second. Is it all right? So this completes the numericals of this chapter. Thank you.